Good morning. How are you all doing? Hi, I'm Andreas. I'm going to talk about Nix plus Bazel today. I work at Twig in the Scalable Builds group. So yeah, let's start with Bazel. That's why we're all here today, right? So you all know this. Bazel's tagline: fast and correct, choose two. Why do we care about fast builds? Well, I mean, clearly it's a waste of time to sit there waiting for your compilers to finish. You get distracted, do something else, right? That's bad for productivity, so we want fast builds. Also, having to rerun builds all over again is expensive, so we care about that. But why do we care about correct builds? Let's start with a little story, what it might be like working on a project that's not built with Bazel. Let's say you're working on your code, on your product, and you notice that some parameter needs tweaking. It's not behaving the way it should, and so you decide to adjust it a little. So you edit the file that contains the parameter, and you rebuild your project. Let's say it's a project that uses make. So you run make, and you notice, strange, nothing changed. What happened? Well, it turns out you've set your parameter in a header file, and you've just forgotten to tell make that, this header file is actually a dependency of my build action, right? So it was an undeclared input. That happens. And your build is now incorrect, right? The sources and the generated artifacts, they no longer correspond. That's a somewhat simple and harmless example, but you could imagine this could be worse, right? You could be deploying the wrong thing to production or something like that. So correctness is important to get what you actually want to produce. But correctness is also important because in such a situation, if you run your builds on CI or you want to run CD or something, you cannot really trust that an incremental build is going to produce the right thing. So you actually have to build from scratch every time you want to produce something to deploy, right? Because otherwise, who knows what's going to end up in production. So you cannot easily cache your builds in such a situation. So the fast really depends on correct, right? So Bazel makes builds fast by using aggressive caching, features like remote execution and so on. And those features depend on your dependencies being complete, your declared dependencies being complete, right? Okay, so what went wrong in this case? Well, the build system did not keep you from forgetting to declare this header as a dependency, right? And how did that happen? Well, the build was allowed to run and access that header file even though it wasn't a declared dependency. So the build was not hermetic, right? It was not isolated. Undeclared inputs went unnoticed. So yeah, this term, hermetic, what do we mean by that? We mean there should be no external influences on your build. So the build should not be allowed to see undeclared inputs. It should run in isolation. And this helps make your builds deterministic, and it helps make your builds correct. All right. So what does Bazel do to help us here? Bazel sandboxes its actions, right? The actions are run in isolation. Undeclared inputs are not visible. Yeah, that makes those builds hermetic, right? Or does it? Well, let's look at another story. This time a project that uses Bazel. And let's say you have a new joiner join your company. They're new to the project. They do the first setup. They do the first checkout of the project. And they run a build. And the build fails. They get a linker error, missing symbols. So they're confused. They ask a colleague for help, and the colleague tells them, oh, yeah, I forgot to tell you. You need to install this system library. You need to make sure that this system library is installed. All right, so they do that. They install the library. They run the build again, and this time it succeeds. Now they run the tests, and they notice, the tests fail. That's confusing. So they ask their colleague again, and the colleague says, yeah, sorry, you need to install a different version of that library. Depends on a particular behavior there. Apologies. Not a problem. The new joiner upgrades the library to the right version and runs the build again, but notices that, nothing actually changed. Build didn't even run. Well, turns out the problem here was that we didn't tell Bazel that the system library was a dependency. So when we changed it, Bazel didn't know to rebuild it. So the build was still not hermetic. So the problem there is that, yes, Bazel does sandbox the builds. Yes, it isolates them from undeclared dependencies within the project, but system dependencies, it's pretty lenient on. So you're going to have stuff like user bin, user lib, these things are going to be visible, at least in the default standard setup. Yes, you can put in a lot of work to prevent it from doing that, but by default, you're going to find that too many tools are visible in the sandbox. So what do we have to do to achieve correct builds with Bazel? Well, we must be vigilant, right? We must configure our tool chains to not look into global paths. That can be quite difficult to do. We might need to Bazelify our external dependencies, our library dependencies. Maybe we even need to migrate them to Bazel, or at least wrap their builds so that Bazel builds them. But that can be quite costly. Or we can make them explicit imports from the system, so that Bazel at least knows to rebuild if something changes or to fail if it's missing. But it's still somewhat of a partial solution, right? Because you still need to remember to install that thing in the first place. Or a common solution is you can enforce a homogeneous environment, right? You just tell, okay, anyone working on this project, they need to have this system, period. Either your IT or through a Docker or whatever, you make sure that everyone is running the builds in the same environment, and then these things don't really happen. But that's not really a great solution either, right? Docker images, yes, so long as you use the same image, it's going to be the same build, so in that regard, it's reproducible. But if you need to add a library, you need to rebuild your Docker image, right? If you rerun your Docker file and there's an apt update in there, then who knows what you're going to get this time, right? So it's going to be a new build, essentially, and it's very coarse-grained, because this way you potentially change the entire system image and potentially have to rebuild the entire project from a clean build to make sure that really you still get the correct output. So is there a better solution? Well, let me introduce Nix to you. Actually, in fact, how many of you have heard of Nix already? Hands up. All right, that's nice. It's like maybe half the room or so. So what is Nix? Nix is a project that was started by Elke Dolstra in 2003. So it's been around for a while. And Nix is a couple of things. It's a configuration language. That configuration language is used to define packages like system libraries and so on, define how to build them, and define what they depend on. And this configuration language is a purely functional programming language, and we'll talk a little bit more about that in a minute. Nix is also a package manager, which installs and manages packages that are defined in this Nix configuration language on your system. With Nix, you also get access to Nix packages, or Nix PKJS, which is a huge package collection. It's an open source project. You can find it on GitHub. And all the packages in there are declared using the Nix configuration language. It's fully declarative. Everything is pinned in that repository in source, all the versions, revisions, hashes, and whatnot. It's also very easy to contribute to. It's just a Git repository, right? So it's very easy to add a package. And it provides a community cache, so you don't have to rebuild everything on your machine. You can download binaries, or you can set up your own binary cache if you prefer to do that. That's possible. And then there's also a Nix distribution built out of all of this called NixOS. And it uses the Nix language and the Nix package manager to manage its packages, but also its system configuration and to manage services that are supposed to be running. All right. So what's so great about Nix? Well, it's designed to be reproducible. Builds are really built in isolation. Packages are really built in isolation. The sandbox is very strict. You're not going to find undeclared dependencies, and you're not going to have the "it works on my machine" kind of problem. It's declarative. Packages are defined in the Nix language, a purely functional programming language. And the way it maps packages into the space is sort of to say dependencies of a package are the parameters to the function that defines that package. And then if you execute that function, the result is sort of a build script to execute to generate the package. So it's quite similar to Bazel in some regards. And it's designed to be reliable. What's cool here is that the way Nix installs those packages on your system is it puts them into paths that include a hash of all the inputs to the package definition in their path. So it's very easy to install the same version, to install different versions of the same package next to each other without conflict. And it applies memory management discipline to software deployment. So it says, I can detect which package depends on which other package because of these hashed paths and so on. And I can do things like garbage collecting your package set. If you don't anymore depend on a package, then it can remove it and its dependencies. And when you install or update packages, your package store is never put in an inconsistent state. So you can always roll back. If something goes wrong, it's not going to be a problem. So how is this relevant to us? Why do we care about Nix when we're using Bazel? So we're going to focus on the package manager aspect of it. And as I mentioned before, Nix is very strict on its sandbox. Because the use case it's targeting is a Linux distribution, right? A multi-user operating system. So it has to be very strict there, and the community binary cache. So it isolates fully isolates the file system, network, and more. And the package store is self-contained. I mean, of course, there are some exceptions, like you're still going to use the host system's kernel, but it's very easy to say, okay, I'm going to use this package provided by Nix, and it's not going to depend on anything else on my system that is not managed by Nix. So it's very easy to obtain hermetic toolchains, hermetic library dependencies this way. And then it provides this huge collection of packages, NixPKJS, which according to Repology, it's the largest package collection among the Linux distributions. It's also very up to date, so you're going to find fresh packages. So chances are you'll find what you need, you'll find your dependency, or if not, you'll find something that's similar, so it's easy to essentially create a copy and change it a bit. And if all that fails, then there's still a great community that can help you define packages. So we think combining the two sort of covers the aspects that I mentioned before that we could see as Bazel's weak spots, where yes, it's strict within the project, but when it comes to system dependencies, it's not so strict. With Nix, we can cover that whole. All right, so we combine Nix and Bazel, where we use Nix as a great package manager to provide your system dependencies and toolchains and so on, and Bazel as a great build system that gives you fast incremental builds, the single language for your project, and the ecosystem of rules, and all these great things that we like about Bazel. So yeah, Nix technically also a build system, but really more designed with the package manager use case in mind. So at least at the moment, Bazel gives you a better incremental build in development. Yeah, we like to combine the two. So how do we do this? There are actually two ways in which you can combine Nix and Bazel in your project. One way is to provide the developer environment. So when you want to work on a project, there are a couple of tools that you're going to need, right? Some, I don't know, linters, formatters, whatever, but also your build tools, right? You're going to need Bazel somehow. So Nix can actually be used to provide this developer environment. So you can provide Bazel itself, and you can also provide other kinds of tools that you might want to invoke as a developer on the command line directly. So what does this look like in code? Here we have a Nix file, commonly called shell.nix, that defines a developer environment. And the first thing it does is it pins a particular Nix packages collection that's importing a different file. It essentially contains a revision into hash, saying which Nix package collection you want to use. And then it defines the packages that you want to import into your developer environment and make available. In this case, that's Bazel and let's say Buildifier as an example. All right, and then there's another way in which you can combine Nix and Bazel to achieve hermetic builds, which is to use Nix to provide your system dependencies, libraries, toolchains, and so on. So at Tweak, we maintain the rule set rules Nix packages, which allows Bazel to invoke Nix to import packages. And this can be things like toolchains, GCC, or the Python toolchain or whatever. And it can be build tools or libraries. So what does this look like? Like setting up a C toolchain in Bazel is often not so easy, especially in a way that's hermetic and reproducible. But with rules NIX packages, in this example, you can use the NIX packages CC configure macro or repository rule that's exported by rules NIX packages, and it's going to set up a C compiler toolchain with a NIX packages provided C compiler. By default on Linux, that's going to be GCC, on macOS Clang, but you can configure that. And what's nice about this is those familiar with the way the Bazel CC toolchain works is at least the standard one sort of has a bit of a configure step where it figures out a bunch of settings. All this kind of setup in the NIX case is done within the NIX sandbox. So it's really strict. It's not going to depend on any undeclared dependencies that you happen to have on the system where you're running the build right now. All right, so what does this look like conceptually? Bazel is going to go through rules NIX packages to invoke the NIX package manager. That NIX package manager is either going to build or fetch from the binary cache your CC toolchain and the configuration. And then through rules NIX packages will pass that back into Bazel, where Bazel then configures it as a toolchain and can use it if it chooses it at toolchain resolution. All right. Another example is to import a system library, let's say LZ4. So here we're using the quite general NIX packages package workspace rule that is going to import a NIX package into Bazel, and then you can define this build file snippet there to say that this is supposed to be a C library that you want to use in your build. And then at that point, it's a regular Bazel target, and you can just depend on it in your Bazel project. And this works analogously for build tools as well. If you want to have some binary that you need to run for, I don't know, integration tests or something like this. If you want to hear a bit more about that, then you can also look at my talk later today about hermetic shell scripts. All right, so let's go back to that new joiner story that we had in the beginning. What might the new joiners experience be in a NIX plus Bazel project? Well, the first thing they're going to have to do, of course, is to install NIX on their system. And then they're going to check out the project, and they're going to enter the developer environment, the NIX shell. For example, you could use dir-env integration to make that automatic. There are a couple of ways to set this up. And that is going to fetch Bazel and other developer tools that you defined at this point and make them available. Then they're going to run the Bazel build. Bazel is going to use rules NIX packages during the fetch to pull in the C toolchain or other kinds of toolchains or library dependencies that you might have through rules NIX packages. Then they're going to run the test. And yeah, it's all going to work. They're not going to have to worry about installing any kinds of system packages themselves. It's all pinned in source with Bazel and NIX to make sure that they get the same results as other developers in CI. And because of that, it's also very easy to benefit from shared remote caching, even if your contributor is coming from a different Linux distribution. I mean, it depends on the setup whether that's a concern, but in some teams that might be a concern. So what are the benefits of this approach? You get a consistent developer environment and toolchain and tool and library dependencies. Your project is explicit in the dependencies also when it comes to system dependencies. You're explicitly saying your project depends on these things provided by NIX, and even more, you're explicitly saying these targets depend on those NIX provided system dependencies. So that also means if you change any of them, you're not going to have to rebuild your entire project. It's going to be incremental. It'll only rebuild the things that actually depend on the change dependency. And you benefit from that huge package collection that I mentioned before. It's reproducible because everything is pinned in code, all the versions of your dependencies and everything. You can go back in time. If for some reason you have to debug an issue that where you need to check out code from a month ago or so, you can just check out that code, rebuild, and it's going to be as it was back then. It's going to use the same versions that were the declared system dependencies at that time. Yeah, it's fine-grained, as I mentioned before. If you change a system dependency, it's only going to rebuild those things affected. And you get to benefit from the shared remote cache, even on heterogeneous environments. So this can be very good for open source projects, for example. In fact, there is an open source project where I worked on where even external contributors using a completely different Linux distribution can still benefit from the binary cache, Bazel and Nix cache, that is populated by CI, because Nix enforces the environment, so it's going to be consistent and will work. Are there any caveats? Well, yes. Windows support right now is not really a thing with Nix, but it does work on Linux and macOS. And just yesterday, I heard that there are use cases with WSL where it apparently works. But yeah, native Windows at least, is not really supported at the moment. But Rules Nix packages is designed in such a way that at least it will get out of your way if Nix is not available on the platform. So it is possible to set up a project where on Unix, like Linux and macOS, you provide your dependencies through Nix, and on Windows you use something else, and Rules Nix packages will get out of the way. It will not crash with weird errors like Nix not found or whatever. And another caveat is that remote execution is still somewhat of an open question. As far as Bazel is concerned, these packages that we provide by Nix are external to Bazel. Because Nix installs these things under a separate path on your system. And so when it comes to remote execution, Bazel doesn't know that it's supposed to make sure that these dependencies are present on the remote execution side. Those who were at the community day yesterday, there was a discussion about that as well, which I thought was really interesting. Yeah, so you need some other mechanism to ensure that your dependencies exist on the remote execution side. A colleague of mine, Guillaume Moudou, gave a really good talk about this at Bazel Exchange earlier this year. So if you're interested in one possible way of setting this up, go have a look at that talk. Okay, so how can you get started using Nix plus Bazel for your project if you're interested? We have a couple of resources out there. Yesterday, we open sourced our Nix plus Bazel code lab that we've been using internally for a while now to train people on using this. It's an adapted form of Google's Bazel code lab, but it's set up as a Nix plus Bazel project. So toolchains and so on are provided via Nix. The tutorial itself focuses on the Bazel side because it's intended as a Bazel code lab, but you can look at it and see sort of what a Nix plus Bazel setup looks like and how it is to work with Bazel in such a setup. Rules Nix packages, the repository, contains a couple of examples for different toolchains that you can take a look at. And of course, there are also API docs. And then finally, the Nix website is a good resource to take a look at and find documentation, learn more about the concepts behind it, what it's trying to achieve, and so on. All right, so in conclusion, with Bazel, we have a great build system that provides fast and correct builds, fast incremental builds. It's strict about dependencies within your project, but it is lenient when it comes to system dependencies. So to make sure that your build is really hermetic and reproducible, it puts the burden on you when it comes to system dependencies. And with Nix, we can shift that burden onto the Nix package manager. It has a strict sandbox. Packages are built in isolation. And so you get a hermetic build also with respect to the system dependencies. So if you combine Nix and Bazel, you get the best of both worlds with fast incremental builds and correct and reproducible builds. Quick mention, I work at Tweak in the Scalable Builds group, and if you're interested in what we do, then take a look at the Tweak blog and this blog post in particular, or reach out to me while I'm here. And we're also hiring, so if this sounds interesting to you, then take a look at our careers page. Or, again, get in touch with me. And yeah, with that, thank you.